Hello, everyone, and welcome to another edition of our Azure Administrator Study Series. So, I hope you guys had a wonderful day and you're ready for another wonderful session from our wonderful Sir David. So, like always, make sure you hit the thumbs up, subscribe to our YouTube channel, and you'll be great to do that because you're always going to get these Azure free sessions essentially. So, Sir David, what do you have in store for us today?
Hey, hello. How you doing, sir?
Yeah,
Honorable
doing very
Coffee.
well. You
Busy day as always.
really
Yeah, it's
an easy day
it's
for you. It's been a
yeah.
very long day for me. Yeah,
What customer having issues?
yeah.
All
You
those
know
things
how
going
it
on.
is. Yeah, uh, and yeah. How
The
about you? How was
issues.
your day?
Yeah, it's been absolutely busy trying to complete like some project work that I have going over here. Trying to complete it before Thursday.
Oh,
So
okay.
just been doing multiple things at the same time and
Well,
stuff.
well,
Yeah.
if anyone can do multiple things, it's you, sir.
But it's a bit different also. Yeah. So what we're doing today? So because today we're going to start looking at, we're going to continue with where we stopped
That's
yesterday,
right.
looking at designing network solutions in Azure. So yesterday when we started the conversation by just talking about network connectivity. Right, we talked
That's
about
right.
inbound internet network connectivity, outbound internet network connectivity. So we talked about those yesterday. So we also talked about hybrid connectivity. So that was when we started looking at Azure ExpressRoute yesterday. So I think that was where we were able to get to before we had to stop yesterday. So, but what we do is that we'll pick things up from the conversation that we were having about Azure Express Route. So, pick things up from there, and we're going to conclude the aspect of Azure Express Route information, and then we're going to go into designing for traffic management in Azure. So, essentially, that's sort of like the plan for today. So, let's see how we get on with that.
Absolutely.
Yeah. So, I'll go ahead and share my screen now. So, can you see my screen? I think it should be coming up now.
Yeah, I can see your screen.
Yeah. And before I forget, just to plug this in, there's a book. It's an Azure security book that I wrote. So it's been published by Pact. So it's a book that covers the Microsoft Azure security engineer certification. But it goes beyond that. It actually talks about some practical things relating to Azure security. So I am hoping that at some point, maybe before it goes to release, I will be able to get stuff. But essentially, you can just go ahead and order like the
Pre-order.
pre-release. Yeah, you can do the pre-order, and then that'll be posted out to you if you order the paper copy. If you order the Kindle edition, that'll be automatically delivered to you on that date that we have over here. So everything is going well. So it's all looking good. So just to mention that.
Yeah.
Okay. Yeah, sorry.
Did you post
Go
the
get
link
it.
last week? Actually, yesterday into the
Oh,
chat.
that's true. Did I post the link? Let me go ahead and post the link right now. You know, I'm just a young little African boy trying to be like Sarkozy. That's just trying to get to Sarkozy's level. So that's all. It's all the hustle and all the stuff. Sarkozy didn't need to hustle for you. He's got like a farm with gold. That's life for you.
Don't worry. I'll actually release a book about how to make gold.
That would be awesome. We can forget about all of this stuff, right?
Go straight to the money.
Exactly, right? Because all of this is sort of like you're taking like a journey to get to that. If you can get the gold directly
Yeah,
without having to go through all this Azure stuff,
exactly.
you
Why
know.
go through all these moves when you can go straight to the target?
So I'm concerned that there will be like a little boy that's looking forward to getting into IT hearing us talk. And the poor boy or poor girl will just be super discouraged and go, I
No,
should just go for the money. Forget about all this nonsense. Just go straight for the money. Okay. Anyways, so okay, let me bring up the slide again and where we're talking about. So yesterday we're talking about Azure Express Route. So talking about hybrid connectivity options in Azure. We said Azure Express Route provides a private and resilient way for us to connect on-premises networks to the Microsoft Cloud. So you have an on-premises data center network. You want to connect that to your virtual network in Azure. You do not want to do that over VPN. We'll talk about the differences in a few minutes. So you do not want to go through VPN, and you want to use a private wide area network connection, similar to like your MPLS style connection. You can use ExpressRoute.
And also,
So
can you use this ExpressRoute in place of peering? So just in case you want to connect to two network VNet within different region, right? Can you go extreme and use ExpressRoute for that?
um, can ExpressRoute provide? Can it be used to facilitate connection between two networks in Azure? Yes, it can help to facilitate that. But that's not like its key objective. So remember the slide that I showed to you yesterday. So I showed
Yes.
you the slide yesterday on Express Route disaster recovery architecture, right?
Yeah.
So you have a disaster recovery architecture over here, where you have Express Route connection over here. And you can see that because this ExpressRoute connection, it's using ExpressRoute Premium, like we mentioned yesterday.
Yeah.
You can use it to connect to virtual networks outside the geography or the geopolitical region where the ExpressRoute itself is located. So in that case, this is linked to your Azure Virtual Network over here. And then this is also linked to your Azure Virtual Network over here. And then using, your route tables, which can either be static entries or using Azure route table or using BGP for automatic, for just automatic route distribution. Then, you can facilitate connection that way. Is this like the main use case for ExpressRoute? No, right? It's not the main use case. You can use it to achieve that, but it's not the main use case for that. If that makes sense. Does that make sense?
Yeah, it makes sense.
Yeah. Yeah. So in the particular case that you're talking about, so VNet peering, you can just use it to pair both of them together over the Microsoft backbone network, and then you have that connectivity directly that way. If that's just the simple use case. But in this case, what this organization is trying to do in this case, Kofi, is this organization has multiple networks, right? You have multiple locations, and you want all those networks to essentially be able to route to one another, be able to reach each other, right? So essentially, you want to treat them as this massive global network for the organization. That's when something like ExpressRoute comes in. So we have on premises, maybe we have a co-location, a colo data center over here. Let's say this is in the US, and let's say this is in the UK. We have another data center location with networks over here, and then we are using Azure region. Maybe we're using the UK South Azure region, and we're using the East US Azure region over here, and we're running production workloads, right? So maybe, we're doing certain things here, we're replicating them over here, we're doing certain things in this other place, we're replicating them over there, and they need to be able to consume services across other networks. So we essentially want to treat them like this global single network. ExpressRoute comes handy with that. Is ExpressRoute the only way to do that? No. So there are other options like, you can just use VPN, and VPNs are, popular these days because the internet is getting faster and faster these days. And the other stuff, we just need to be careful not to get because 5G is very dangerous with the internet getting. I'm not sure. Some people think that 5G. Angelica actually likes your idea, Sakofi. Angelica likes the idea of going straight to the gold. Forget about all this other stuff and stuff. So that's where ExpressRoute comes in. So let's go back to the other stuff that we're talking about. So let's go back over here. So if I go back to that connection over here, sorry, to that slide. So, and with that ExpressRoute, it's not something, many cloud services are coffee. There are things that we can just do without involving anyone else, right? You want to set up like a VPN connection between your home network or between your office network and your virtual network in Azure. You don't need to involve anyone else to do that, right? Create your VPN gateway. You have a public IP on your office network, IPsec connectivity between them, all of that stuff. However, with ExpressRoute, it relies on a relationship with a connectivity provider, right? And then we have the connectivity provider that we need to walk through, that will set up like edge routers on her side, and then we can use that to connect to the edge routers on the Microsoft side. So, and we mentioned that ExpressRoute can not only be used to connect to our private networks in Azure, but can also be used to connect to public Microsoft Cloud services. So one of the points that I emphasized on yesterday is that with ExpressRoute, there are two main things that we're paying for. We're paying for the bandwidth that's allocated to us, and we're paying for the outbound data transfer. So Microsoft, like other cloud providers that are out there, they do not charge for data that you bring into Azure, right? So, bring your data. Because wherever the data goes, typically the application follows, right? So that's the plan. So bring your data for free. However, if you're moving data out of Azure, so whether you're moving data outside an Azure region or whether you're moving data outside of the Azure cloud itself, there is a charge, and that also includes ExpressRoute. With ExpressRoute, so essentially you're paying for the bandwidth that's allocated, and you're paying for the data transfer. And yesterday we saw the two options that we have. So we can pay for unlimited data transfer, which means we don't need to worry about how much data that we're actually transferring, or we can pay for, we can do a pay as you go. So, we pay for the actual data that we are transferring on a pay as you go basis. So then yesterday, we also now went to look at the different types of express route connections that exist. So we saw yesterday that we have the different SKUs. We have the standard and we have the premium. And we mentioned yesterday that standard has geo connectivity within a geopolitical region, while ExpressRoute Premium has global connectivity, right? So, and an example of that is you have a virtual network in West Europe. You can link that with an ExpressRoute circuit that's in Silicon Valley, for example, right? Because you're using Premium, which has global connectivity, right? And that plays into disaster recovery scenarios. So ExpressRoute also has different connectivity models. So it's not just one connectivity model. So here are the three connectivity models that it has. It has the Cloud Exchange connectivity model. It has the point-to-point connectivity model, and it has the any-to-any connectivity model. What's this about? What's the differences between them? So you can see the Cloud Exchange connectivity model is going to, essentially, this is sort of like you're connecting to your provider using layer 2 connection, right? It's sort of like layer 2 tunnel to your provider, and then your provider handles the layer 3 connection between the Microsoft Cloud and your environment. So that's sort of like how that works. So with the point-to-point, it offers, so depending on the provider that you go for, it can offer layer 2 connection or layer 3 connection between your site and the Microsoft Cloud, right? And then we have the any-to-any connection, which is plainly layer 3. So this is the one that is the equivalent of like MPLS, where you have MPLS connection between this. So what's sort of like the main differences between them? The main differences between them, it's mainly, for example, let's say, Sarkofi, you have multiple networks that you want to connect together, right? This model will probably fit you better because with this model, with this point-to-point connection, for example, let's say you want to connect to multiple networks, that would take like multiple connections for you to achieve that. Right? So because you have to do point-to-point connection, so a single connection for each connectivity that you're establishing, right? Whereas with this one, what you're essentially establishing is you have this wide area network. With the any-to-any connection model, you have this wide area network, and then you're having all these different networks connecting into the wide area network. and this sort of like becomes sort of like the central hub for them. So that's why it's called any to any. So any of this network over here can reach through the wide area network, can reach any of these other networks as long as they're part of that same wide area network. Whereas with this one, you're doing point to point, which is this one is connecting to that one. This one is connecting to that one. So, which can essentially, if you have multiple networks to connect together, your costs can skyrocket, if that makes sense.
That's right. Yeah.
Yeah. And stuff. So, that's sort of like the different models that exist out there. So, when we talk about disaster recovery, which I showed you the slide earlier, so when designing for disaster recovery with ExpressRoute, there are certain things to take into consideration. Number one, you want to ensure that you use geo-redundant ExpressRoute circuits, and you want to ensure that you have geo-redundant ExpressRoute circuits. What do we mean by that, Sakofi? Here's what we mean by that. If I have, let's say, for example, I have my important production workloads over here in my data center, and I have important production workloads in the UK South Azure region over here with my virtual network. If I have an ExpressRoute location, let's say that's based in London, and I have only one, right? And I'm having this connection over here. Essentially, if something were to happen and impacts this, that really impacts that connection, right? Because essentially I have this single one between London and my UK South virtual network. So what this is saying is I may want to consider, depending on my budget, maybe I can have an ExpressRoute location in London. Maybe I can have another one, maybe if I have the money, let's say in Silicon Valley, or maybe like in Asia or West Europe or somewhere else, right? And then I can now have redundant connection. So where this is still connecting me to this, so that essentially I have like a backup link. If this were to fail, I can essentially, with BGP routing, it's going to discover that, and then it's going to redistribute essentially the traffic to be able to flow through this one. Does that make sense?
Yeah, it does.
Yeah.
Most often, many companies prefer to use VPN as a backup, right?
Yes. And actually, it's not, I tell you, like, even VPN, I think, in my own opinion, I think VPN will be like probably like the preferred option that people are going to be using these days. So if you think about it, Sakofi, right? Well, it depends actually on the company, but in majority of the situation, when it comes to like user workloads, the age that we're in the world, user workload is not going to be centralized in an office location anymore.
That's right. Yeah.
Right. It's going to be distributed. People are going to be connecting. There are new services that people are releasing, that security companies are releasing, where you can send like a router to your users at home, so they can use that, plug that in, and it's going to do automatic VPN connection somewhere or something like that.
And also, some of them even go further, like using layer 2 as well.
Yes. Yeah, exactly. Yeah. So, even though you can use VPN for backup, but essentially this is just saying, depending on, your use case, if you have like deep pockets, like the SAD we're speaking to, you may actually just go ExpressRoute everywhere. So the other thing that you may want to consider is using diverse service providers, right? So for example, in case like there's a wide issue that's affecting the service provider that you're using, if let's say this one is service provider A, this one is service provider B. So hopefully if service provider A is having an issue, it's not affecting service provider B. So then you can use that, right? And then you can use that. Oh, okay, I can say good question. I'll address that in a minute.
So, Gaston was saying, or VPN to backup ExpressRoute.
Yes, so that's definitely an option. So instead of using two geo-redundant ExpressRoute circuits, you can use a single ExpressRoute circuit and then use VPN as backup for that. So that's absolutely fine to do that.
Yeah, and got a follow-up question. I said, what's the difference in use and uses case with Azure Virtual One service?
So good question. The Azure Virtual One service, essentially, however you put it, Azure Virtual One service, essentially what that is, it's dynamic VPN. That is what Azure One is. Azure One is dynamic VPN, right? Dynamic VPN, right? So what that means is you have this sort of VPN service that I can have my site over here connect using IPsec VPN to this Azure Virtual WAN service. So it's using IPsec. So in other words, this is going over the public internet, right? Remember that public internet, there's no way for you to really have guaranteed SLA. That's one of the differences between ExpressRoute and IPsec VPN is that, with ExpressRoute, you can have, guaranteed bandwidth, guaranteed SLA, around that, right? So that's one of the differences between them. So, however, this also has the advantage that once you have all these different IPsec connection that's coming from your different location connecting to this Azure Virtual WAN service, and then you can have sort of like, because it's dynamic, let's say there were to be like a failure where maybe there's like let's say you have another service over here where this is connected over here, and there were to be a failure where this fails, it can automatically fail over the connection using the other option. So essentially, this is VPN that's dynamic, but at the end of the day, it's still VPN, but it's like much more dynamic VPN versus just statically connected VPN. Whereas ExpressRoute provides private wide area connectivity with SLA, with guaranteed bandwidth, and all of that stuff around that. So let me bring up this document to do sort of like the difference between ExpressRoute, and VPN, and so that we can see like sort of like the use cases and what Microsoft has to say about that. So let me bring up this option. And let's see. So I think that the document that I'm seeing here, that's a very, very old document. We need a document that's much more clearer. Let me see if I can get that up here. There's a nice document that Microsoft has, but I can't find that document. Okay, I'll look for that document and I'll bring it up. So, ExpressRoute is private wide area network. It's not using public internet. It's going over private one. So let's quickly cover this so that we can move on. So, designing each of the ExpressRoute circuit for high availability. So one of the things that you notice with ExpressRoute circuit, let me remove this. Let me go bring up the other slide. One of the things that you notice is that with ExpressRoute, let me bring this up very quickly. You notice that the connection between the Microsoft Edge router and the service provider, the local edge routers over here, the connection is always redundant. So this connection is always redundant over here. And the connection between the ExpressRoute gateway and the Microsoft Edge router, this connection is also redundant. I'll just put red for redundant. However, it is up to you to ensure that the connection between your on-premises device and the local edge routers, that connection is also redundant. Otherwise, what you have is you have redundant connection over here, redundant connection between the Microsoft Edge and the local edge. However, you have a single connection here, which essentially defeats the whole purpose. Because if that single connection were to experience an issue, then you have an issue. Then the other thing that you have to ensure is that it is probably worth considering, instead of using a single device over here, to have multiple devices, right? So that way, if this device were to experience an issue, you have this other device that actually has, so you have the redundancy or split. So essentially, the redundancy on all the other hands is taken care of. The one that you need to focus on is the redundancy between your endpoint on premises and the local edge routers, and it's up to you to ensure that you make that redundant also. I'm sure that, yeah.
What about the power source? Electricity provider.
Yeah. So that is, I wanted to say something about be quiet. I wanted to say that if it's like my beloved country, it's okay. I'll be quiet, Sakofi. I'll be quiet. I will be quiet. Okay. So let's move on very quickly. So there are many other things that we can talk about, but I'm looking at the time. So let's go talk about designing for. Let's go talk very quickly because I want to cover some other parts before we go. So right now I'm going to go to talk about designing network traffic management. So if you're interested in finding out about designing name resolution, go have a look at the Azure Administrator live study. I went into a lot of, or Pastor Kofi and myself, we went into a lot of details on designing for name resolution. And, Kofi had a nice lab on that, on even private DNS zone and public DNS zone. And we actually covered the whole range of DNS options in Azure. So if you're interested in that, I highly recommend that you check out that video. But however, for now, I'll move over to talk about network traffic management. When we talk about network traffic management, we're essentially talking about load balancing. That's what we're talking about. Talking about load balancing. What is load balancing? Distributing traffic to multiple endpoints. Maybe that for availability reasons, right? So you have multiple endpoints that you want to distribute traffic to. Maybe that's for scalability reasons, right? So you don't want to overload a single instance. You want to be able to distribute load across multiple instances so that way you can handle more requests than a single instance can handle. So whatever the reason, you have network traffic that's coming in and you want to ensure that you can distribute that across to multiple instances. Now in Azure, when we're talking about architecture, there are two main things you need to take into consideration. Do you want to distribute traffic to global endpoint or to regional endpoint? So that's important. In Azure, the Azure cloud is made up of data center regions, right? We have the West Europe data center region. We have the UK South data center region. We have the South Africa data center region. We have all these different data center regions, right? There are certain load balancer services in Azure that can only distribute traffic to instances within a region. So those are called regional load balancing services. You have load balancer services in Azure that can distribute traffic or network traffic to endpoints on a global scale. So it doesn't matter whether they're in the same region, they could be in different regions, they could actually be in different clouds. So maybe you have one of your endpoints hosted in AWS, another one in Google Cloud, another one in Azure. It could even be some endpoint hosted on your on-premises environment. So then you need global load balancer services that can handle that. The other thing to consider is whether the traffic that you want to distribute, whether that's HTTP traffic or non-HTTP traffic, because that's also important. There are certain load balancer services in Azure that only accept HTTP traffic. So they do not accept non-HTTP traffic. They are expecting traffic to come in on port 80 or port 443. That's the only traffic that they accept. And there are certain load balancers that don't care. They will accept any traffic, whether it's HTTP or non-HTTP, they will accept like those traffic. So they will be able to accept that. So let's quickly go have a look at the comparison between the different load balancer services in Azure, and let's have a quick look at them. So over here, you can see a list of the key ones that are listed over here. We have the Azure Standard Load Balancer. We have the Azure Application Gateway. We have Azure Traffic Manager, and we have Azure Front Door. Now, when it comes to can they load balance across instances that are global, in other words, across multiple regions or just instances within a region, you can see that Azure Load Balancer Standard can load balance across instances, whether that's regional or global. No, so that's a very new one, Sakofi. Because in the past, this used to be only regional. It didn't have the global option. However, it now has a global option, so you can use Azure Standard Load Balancer to distribute traffic across regions. We have the Azure Application Gateway that is only, at the moment, only supports regional load distribution. We have Traffic Manager and Front Door that supports global load distribution. So in terms of can they be internal or public, so you have the Azure Standard Load Balancer that if you're implementing just the regional option, it can be internal or public. If you're implementing the global option, it can be public only. Application Gateway can be internal or public. Traffic Manager and Front Door are public only services. So you cannot implement them in a private way or in an internal way. in terms of do they accept traffic that's HTTP or do they accept traffic that's non-HTTP? So both load balancer standard and traffic manager accept non-HTTP traffic. Both application gateway and front door accept HTTP only traffic. But also because of that, you have special HTTP capabilities like web application firewall. Because application gateway accepts only HTTP traffic, you can use it as a web application firewall. Because front door accepts only HTTP traffic, you can use it as a web application firewall also. So initially it accepts that. And when we talk about the endpoint that's supported, you can see that it varies. So the main thing that I want to call out is that wherever you see IP address or FQDN, what that means is that that service can distribute traffic to your private data centers. So Azure Application Gateway, Azure Traffic Manager, Azure Front Door can all distribute traffic to endpoints that are in your private data center, endpoints that are outside your Azure network or even outside the Azure cloud, right? So because all that's needed is as long as there's network connectivity, they can distribute traffic to that. Does that give a quick summary? Does that give a good summary of what those different options are?
Yeah, it did.
Yeah. So let's quickly go have a look at some of the services and then show you some demo, and then we'll move to the next one. So in terms of what some of those services are, let's have a look at Azure Front Door, for example. Azure Front Door. What is Azure Front Door? So Azure Front Door is a highly scalable, globally distributed application and content delivery network. That's a lot of English, right? What does that mean? Like we like to say, that's very nice. That sounds interesting, but what exactly does that mean? Let's break this down a little bit. Number one is that it's highly scalable. And what that means is you really don't need to concern yourself with the scalability. It's a managed service, right? It can handle the requests that coming in, and that's not your responsibility to look after that. So that's why it's considered to be highly scalable. Number two, it's a globally distributed application and content delivery network. What that means is that this service can handle application delivery and it can handle content delivery. One of the things that people may not have noticed in the earlier slide that I shared with you just now, you notice that when it comes to Azure Front Door, it can not only distribute traffic to public IP addresses, Azure App Service, it can also actually handle Azure Storage Account, right? And things like Azure API management and all the other stuff like that. So the reason for that is that this service can do application delivery and it can do content delivery. So essentially, it's combining. So Sakofi, you can imagine Azure Front Door as combining the capabilities of Azure Application Gateway and Azure CDN on a global scale. So that's what that service provides. So capabilities of application delivery, capabilities of content delivery on a global scale. So that's what it provides. All right. So let's go back to the slide and let's go see how this service does that. So let's go to here. So Azure Front Door. So that's what. So hopefully that definition makes a bit of sense, right? So the other thing about this service is that it uses the Anycast protocol with split TCP and Microsoft Global Network to improve global connectivity and performance for our web application. So Sakofi, hopefully that makes sense to you.
Yeah, a lot of words.
Right, that's what we do to each other. So I can see Angelica said, what's the name? That it's Azure Front Door like AWS CloudFront. Yes, so it would be like AWS CloudFront. So here's the thing: is that so Angelica, you probably need to educate me a little bit here because I'm still going through my AWS studies. Does AWS CloudFront, does it do dynamic content delivery or does it only do static content delivery? Because if AWS CloudFront only does static content delivery, then the equivalent of that would be Azure CDN. Because Azure Front Door does static content delivery and dynamic content delivery. So that's what makes it different from just CDN. because it does both static content delivery and dynamic. So let me know what the answer to that is,
And
Angelica.
also with Azure Front, Azure AWS Cloud Front, does it do WAF?
Good question. That's a very, very good question. So that's a very, very good question. So does AWS Cloud Front also does it have WAF embedded into it? That's a very good question. Coffee. So yeah, so then that can help. So essentially what we're talking about. So here's what we mean, Coffee, right? So I have my endpoint, which has my application hosted on Azure App Service in the backend over here. So that's the endpoint that actually hosts the application, right? When I implement a service like Azure Front Door, becomes the entry point to access my backend application, right? So this is the entry point to access this backend application. And whenever users want to access my application, they go through Azure Front Door. And Azure Front Door will accelerate the delivery of the traffic using the Azure Wide Area Network. Right. So that's what it's doing in the backend. So Azure Front Door has multiple endpoint locations distributed across the globe, similar to a CDN, where you have the point of presence distributed across the globe. So Azure Front Door has multiple endpoint locations distributed across the globe. It uses the Anycast protocol. So that's the reason why the Anycast protocol is called out. So essentially, the same IP address can be serviced from multiple endpoints, right? So you're coming in from Germany, you're connecting through the point of presence that's close to you in Germany, but we're all going through the same we're all going to the same application. So I'm coming to the same application from UK. I'm going through the point of presence that's closest to me in UK, and we're all going through to the same backend, right? So essentially, it advertises that same IP using Anycast protocol, right? On multiple locations. So whenever I want to access that, I go through Azure Front Door, and I go to access my application. And Azure Front Door is going to accelerate that traffic to be delivered to my backend using the Azure Wide Area Network. And what that saves me is that improves my performance, because otherwise, if I want to access this, I have to go over the public internet. So maybe if I go over the normal entry point, maybe that's going to take about, I'm just throwing out a number here. Let's say that's going to take about 150 milliseconds, because that's going to go out through the internet. It's going to go to my ISP, and then my ISP will connect to another ISP, and then another ISP will connect to another ISP, and then that's going to be connecting to all kinds of different ISPs before it actually gets to Azure over there. Whereas what this one does is that it's still going to go over the internet, but it's going to go over the internet to get to a point of presence location that's close to me. So once it gets to that point of presence location, everything else is accelerated over the Azure Wide Area Network, and that becomes quicker. So maybe this is going to take about 30 milliseconds instead of 50 milliseconds that it takes me normally. Does that make sense?
Yeah.
Yeah. And one of the advantages of this service, let's clear up all the ink on the slides. One of the advantages of this service is that we can also integrate Azure Web Application Firewall with it. So what that means is that we can do network traffic security at the point that's closer to the user. So in other words, before we even get your traffic all the way to the application in the backend, right? Let's check whether the actual traffic is not trying to do something dodgy or something suspicious, with Web Application Firewall. So it uses the Corvo set 3.0 over Corvo set. So that's what it's based off. So essentially, it's going to check for things like SQL injection, cross-site scripting, file injection, and all those different types of web application attacks. And it's going to stop those at the edge location, which is the point of presence location where the actual network traffic comes in. And it's going to check that, and only if that's considered to be legitimate traffic will it accelerate them to the backend. Make sense?
Yeah.
Yeah. So that's what Azure Front Door provides. So I want to actually go through the whole setting up everything, but I just want to show you how that works. So by the way, just to help you to understand, so Azure Front Door is going through an evolution. So Microsoft at the moment, they are splitting it out into two. So in the past, it's just Azure Front Door, which is the one that I'll create, which is the one that you're going to be tested on when you do the exam. So there is a new option that's in preview at the moment, but it's not GA yet. So when Azure Front Door, we have two options. There'll be Azure Front Door Standard and Azure Front Door Premium. The main differences between that is that Azure Front Door Premium has more security capabilities than Standard does, right? So that's like the main differences like between Standard and Premium. So actually, let me bring up like the information about that. So Front Door Standard and Premium. So let me bring that up very, very quickly. Let's go to the comparison of the tiers so that you see. But again, this is not GA yet. This is something that's coming down the road. But just to help you to know what's coming down the road. So if I go to expand this, you see the differences between them. You see that when it comes to extensive security capability across WAF, that's only going to be available for the premium SKU. When it comes to bot protection, that's only going to be available to the premium SKU. So you can see that this is like advanced security capabilities. Essentially, the difference between this is, do you just want to do application delivery acceleration, or do you want to do application delivery acceleration plus security? Right? It's the difference. That's going to be the difference between both of them. But that's not GA yet, so just be aware of that. So if I go to front door over here, and I just show you what the creation process of that looks like. Oh, okay. So I can see Kyle saying something.
Yes, so I think in reference to that, I think this one is in reference to the CloudFront. Angelica said, yeah, support dynamic, and
Yep.
and Kai say also support WAF. Right, that's good to know.
Okay. So if it supports both, then that means it's going to be equivalent of Azure Front Door then. Awesome. So that'll be equivalent of Azure Front Door because Azure Front Door also supports both capabilities. So in terms of configuration, it's relatively simple. So you define the front end domain. So this can also, you can specify by default, it's going to have like an endpoint with the azurefd.net domain, but you can also add your own custom domain. So that's fine. So optionally, you can onboard your custom domain, after creation, that's fine. But let's say do web app.azurefd.net. If I want to enable session affinity, I can enable that. If I want to enable web application firewall, I can enable that. So now if you're using web application firewall with Azure Front Door, the way that it works is the policy is decoupled from the front door, right? And that makes sense because front door itself is geographically distributed, right? It's distributed across the globe in terms of the point of presence. So essentially what you need to do if you want to use a web application firewall is you need to go create a web application firewall policy outside, and then you attach it to your front door. So that's the way that it works. And that is good because essentially you're decoupling, the policy from the instance itself. So if you wanted to use that, what you need to do first is you need to go create web application firewall policy. So you need to go create just the policy over here. And then when you create the policy, you can attach the policy to your front door instance. So I'm looking at the time, so I won't bore you with creating that. With Sakofi, we'll work out some good labs that you can do on this.
Yeah. So in terms of the lab, definitely it's coming. So bear with us.
Yeah.
Definitely coming.
Yeah. So with this one, so you can see you can specify what you're creating the policy for. In this case, you can decide whether you're creating the policy for Azure Front Door, Application Gateway, or Azure CDN. If you're creating for Azure Front Door, you select that. You put that in the resource group that you're creating that into. You give the policy a name. So front door policy. Doesn't like the dash, so we just the front door policy. So we leave that. So do you want to set that in detection or prevention mode? You set that. So it has manage rule set as we mentioned. So that's based on the core set 3.0, and that's just all built-in rules. You can also create your own custom rules if you want to. So you can create your own custom rules. And then, you create your rule, you specify the different policies. Maybe you want to specify custom block messages. If the WAF blocks a traffic, do you want to specify a custom error message? You can specify that. You can create your own custom rules as we mentioned over here. So I can go create my own custom rules. Maybe I am aware of a particular exploit, can add that. Then I can go associate it with my front door, which I can do it from here. I can do it from the other side also. So, and then I can review and create that. And that's going to create my web application firewall policy. And then once the policy is created, and then I can enable this, and then I can select the policy that's created, and that's going to link it together. So that's sort of like how that works. So I may need to refresh the page, but I'm not going to be doing that because of time. So I'm just going to click on add to add the front end. So then you had the backend that you want the traffic to be sent to. Come on. Yeah, so that's taking its time. So I want like to just, so there we go. So then you specify your backend pool that you want to send the traffic to. And with all the endpoints that we mentioned earlier, it supports all those endpoints. So where you can go, web backend. And, you can add any of these backend, Azure App Service, Azure Storage Account, Application Gateway, API Management, just public IP address in Azure, Traffic Manager, or you've just custom host, which is even in your private data center and all that stuff. So if I go for public IP address, I believe I have certain public IP addresses over here. And if I go ahead and add that backend, so I can add multiple, but in this case, I'll just leave that. I can specify how to probe the backend to check for its health, specify the latency sensitivity, and then I can specify, the routing rule that is going to use to send traffic to that. So essentially, it's very straightforward in terms of configuration and all that stuff. So routing rule, accept protocol, HTTP, HTTPS, so I can say HTTPS only. After, if I use my own custom domain name, I can upload my certificate if I'm using HTTPS only. And then I can specify which backend to forward to, which protocol to use. Do I want to rewrite it? Do I want to do caching to also help with the optimization? And then once I had that, and then I can just create that. So it's as simple as that, relatively straightforward to create in terms of Azure Front Door. So let's move on very quickly. I'm looking at, we only have like about 12 more minutes. So let's go talk about like some network security considerations. So let's talk about some. Now, some of the ones that I want to talk about in the interest of time, if I just do AZ303. So I want to talk about two main aspects that the exams call out. But the exam calls out two services. It calls out Azure Bastion and also calls out just-in-time VM access under the security option. So I want to talk about both before we actually stop today. So hopefully I'll be able to cover those. Let's go to a quick look. So it talks about implementing Bastion. So a lot of this other stuff, we talked about them in the previous. So we actually spent a lot of time, if you remember, Sakofi, in the Azure Administrator, we went over Traffic Manager, the different routing options. So if you're interested in that, have a look in that video. We covered that already. But I want to talk about Azure Bastion and talk about just-in-time VM access because that's called out as under the network security component of that. So let's talk about that. So what's the issue here that with Azure Bastion that we're trying to solve? There is a risk that's associated with public virtual machine instances. You have a virtual machine instance that has a public IP address. There is a risk that's associated with it. One of the risks that's associated with it is that it's going to be scanned, right? For sure. There's no downside to that. There are bots that are scanning IP addresses. Some of them are good. They're just collecting information. Some of them are really trying to look for vulnerabilities. So it's going to be scanned for the ports that are opened. It's going to be scanned for vulnerabilities that exist. There'll be bots that will be doing brute force attack to see if you're using default credentials. That is going to happen if a resource has a public IP address associated with it. Now, how do we solve this problem in the context of Azure? So you have a virtual machine in Azure. You want to be able to connect to it, to manage it, maybe over RDP if you're using Windows, over SSH if you're using Linux. You want to be able to do that. But how do you do that securely while mitigating these risks that we mentioned over here? You can create a jump box, for example. So you can create a separate subnet over here, put a jump box over there, and then the jump box can be a very, very hardened virtual machine. So you can harden it, make sure that it's patched fully all the time, make sure that you have certain security best practices implemented on that all the time. However, that's going to create management overhead for you because now you have to manage this jump box going forward, right? And that can be a pain to manage. So that's where a service like Azure Bastion comes in. So Azure Bastion allows us to implement secure management connectivity over HTTPS. So let's go through the key points of this very quickly. So at the moment, it only supports RDP and SSH, but you can do RDP and secure RDP and SSH to your workloads using HTML5 without having to expose any public IP addresses on your instances. So the way that it works again is that without your instances needing to have public IP addresses, they can be accessed, their management ports can be accessed. And it's going to go over TLS connection. So as you can see here, the user is going to use the Azure portal and their connection to the Azure portal is over HTTPS, which uses TLS. So there'll be the TLS handshake. And then over the Azure portal, they can request through Azure Bastion to connect securely to the management ports of your private virtual machine instances. So it supports that. Now, Azure Bastion is a fully managed service, so that takes away the pain that we talked about earlier in terms of the management overhead that people have to go through. So that pain goes away. So it also supports connection not just to virtual machines, but to other compute resources like virtual machine skill sets, right? So let me quickly just go over to the portal to show you how that works. And I think that's probably where we'll be able to get to for today. So what I'll do is over here, if I go on the virtual machine section, I have this Windows virtual machine over here. And the Windows virtual machine has a public IP address, which is dangerous, and especially if it's open to everything. So what I'm going to do is I'm going to dissociate that public IP address from this virtual machine. So I'll go to the network interface. I'll go under IP configuration. And then under IP configuration, I'll go to ipconfig1. And I'll go to dissociate the public IP address. And then once I've dissociated that, I'll then go to enable Azure Bastion. So the way that Azure Bastion works is that it's going to create a special subnet within the virtual network that you're enabling it for. So you're going to create a special subnet, and it's inside that special subnet that it's going to have that service created into that. So come on. So while that is thinking about that, let's go start working on Azure Bastion right now. Wow, it's very, very hot, Sakofi. It's super hot.
I think it's going to be like this the whole of this week, I guess.
Oh, really?
Yeah.
I personally, heading out a bit on Saturday.
You have aircon in your house. I'm quite surprised that you still complain about
No, I don't have aircon. It's my wife that has aircon. Some of these lawyers, they have a lot of money in these days. So she's the one that has aircon. I don't. So I'm just over here just trying to get to the gold. So let me go over to my Windows virtual machine now. So it doesn't have a public IP address anymore. So what I want to do is I want to go enable Azure Bastion for this very quickly. So on the left-hand side, if I go over to the left-hand side, if I go over to Bastion over here, so it's going to detect that Bastion is not yet enabled. So, and it's saying, do you want to create the Bastion subnet right now? So, and it's going to create it within my virtual network. So I can go ahead and create a Bastion subnet, and I can go ahead and say, create my Bastion subnet for me. And after it's created the subnet, then it says, do you want to create your Bastion instance? And the good thing also is that it allows us to be able to specify how many instances that we want, right? And we can also specify the tier that we want to create. So it's going to create a public IP address for it. So I'll give it a more recognizable name. So Bastion public IP. And I'm just going to create Azure Bastion using the defaults. And then once it finished creating that, then I will be able to, through the Azure portal, I'll be able to request RDP connection to my instance over HTML5 over the web browser without having to use a public IP address. So, but that is a bit more secure because I have to authenticate to the Azure portal first of all, and that's using again HTTPS, and then I can then securely request that management access.
And that will be over HTTPS, so no port opening.
Yes.
Open up any port.
It's all TLS end to end, so it's all secure connectivity end to end. Yes. So that's only going to take a few moments to create, and then once it's finished creating that, and then that will be done. So while that is going on, let me bring up what are we going to be doing next week. So what are we going to be looking at next week? Let me bring that up while this is creating. Let's go to next week's topic. So next week's topic, we're going to be looking at compute solutions. So designing Azure infrastructure as a service compute solutions. That's what we're going to be looking at next week. So, and then that's going to lead us into designing container solutions, where we'll go to a bit of deep dive on Azure Kubernetes service and other Azure container services. So we're going to a bit of deep dive on them. But next week will be mainly about Azure IaaS compute solutions. So that's what we'll cover next week. Okay, so while that is creating, that's very interesting. So, Sakofi, are you enjoying your Freedom Day? Because today is Freedom Day in UK, right?
Oh yeah.
Oh, this is yesterday.
On Facebook, like Freedom Day, because of the removal of the restrictions, right?
Yeah.
I know why they call it freedom. COVID is not a good thing, so I prefer the restrictions.
Oh, okay. I'm not too sure. Yeah, it's a very interesting one. I think I'm looking forward to getting like my.
Oh, okay. Yeah, definitely, you're looking forward to it. You want to travel?
No, I'll get my second vaccine. I'll get my second vaccine first. So I won't be going out until I get my. So I'll get my second vaccine first. And after my second vaccine, then I'm going to plan. Yeah, but because that's true, Sakofi. So I will be speaking. By the way, I don't think I've mentioned that to the audience while this is creating. I can bring that up.
Yeah, definitely.
So there is a cloud security conference, which, in my opinion, is one of the top cloud
security. Stream anywhere at all?
I think it's going to be streamed also. Yes, it's going to be streamed. So it's one of the best cloud security conferences that's out there. So it's about looking at limitations of security. So essentially, this is not like a marketing stuff. So this is more about actual research. So people that have done attack and defense research on cloud providers. So that's what this conference is about. So I submitted like a talk, myself and one of my good colleagues that we work together, Carl. We submitted a talk, and this year we'll be speaking together. So Carl and myself will be speaking on introduction to Azure offensive security. So that will be myself and Carl. So that will be taking place in Salt Lake City in the United States. So in case there's anyone that's joining or watching that's in that area, if you can out to that will be good. So I'm hoping that I'll be able to attend that conference in person. That'll be good.
What do you mean? But you should be there, or you can do it remotely.
Yeah. So I may have to, because it depends. You know that United States still have UK blocked. So UK is still on the block list. Yeah. So for example, I can't buy the ticket now because UK is still on the block list.
Really? That's incredible.
Yeah, exactly. UK is still on the block, so you're not allowed to from UK. So we're talking about life and death. People don't care about
2 months from now, right? September.
Yeah, it's exactly. So that's what I'm hoping is that hopefully, like the numbers, the UK numbers have been going down. So hopefully the numbers keep going down, and then hopefully like US will see that. So and US will,
Krishna said, can you share the link? And
yeah,
also, you just said, all right, cool.
yes. So this is taking quite a long time. I'm not sure why it's taking a long time to create, but I think it's in a few minutes you should create. Yeah, so that'll be interesting. So because I'll be attending that, so I'll be talking about offensive security. So Carl and myself have some very interesting things to talk about in that area. So some offensive security stuff for Azure.
Yeah,
So how
that's
to attack
so
Azure.
cool.
Yeah. So it'd be good, Sakofi, if Sakofi, we're gonna use your private jet before, but now we're not able to use your private jet. So
No worries.
like private jet, man, Sakofi, that's next level reach.
All right.
That's next level reach, right? Private jet.
When you get to certain level, your time is more important than anything else. So
But how much? Because I hear that even to pack it alone cost a lot of money.
yeah,
Like you have to pay like probably like tens of thousands just to. Yeah. So Krishna, no, don't worry. Yeah, Krishna. So we have some very interesting thing coming out. So just watch out. There's some very interesting thing that'll be coming out on Azure Offensive Security. So I won't give you the full details, but just watch out.
yeah,
So there's some very interesting stuff. So that will be coming out to it. So that will actually have, you'll be able to get practice different scenarios on how to attack Azure from an offensive perspective and workloads in Azure. So, there's some very interesting thing coming out. So, so we'll talk about that. So we're not going to be breaking Azure platform itself. It's more of like you're testing your workloads. So the way that Azure security works is that Azure does like a pen testing of the cloud platform, but it's up to you as the customer to pen test your own workloads. So, we'll be talking about how to test your own workload that you're in Azure. So, Sakofi, this is taking quite a long time, so I'm not
yeah.
going to wait
So
for it anymore.
let's go. Yeah, let's call it a day.
Yeah.
So, ladies and gentlemen, thank you once again for joining our session. So, this is the end of the session for this week. Hopefully, you guys should join us next week. As always, thank you and have a wonderful evening, afternoon, or morning.
Yeah.
Okay, bye.
See you, everyone. Bye for now.